Imagine a company loses $11,000 every single minute a website goes down. Now imagine one person whose entire job is making sure that never happens, while also making sure new features ship faster than ever before. Companies are paying this person up to $140,000 a year, and some are paying far more than that. But wait until the end, and I will describe exactly how to get qualified and land a job in this field. So, who is this person, and why does a company pay this much for someone who isn't quite a developer and isn't quite an IT technician either? Because for decades, two teams inside every tech company hated working together. Developers wanted to ship new features fast, operations teams wanted stability, and refused to let anything risky near their servers. The result was slow releases, constant finger-pointing, and software that took months to go from idea to actual customers. Somebody had to bridge that gap. That somebody is called a DevOps engineer. Let's strip away the buzzword and look at what this job actually is. DevOps simply means development and operations, merged into a single discipline instead of two warring departments. Your job is to build the systems, pipelines, and automation that let developers ship code constantly, safely, and without anyone panicking at 2 in the morning. So what does your actual day look like? You start by checking your deployment pipeline, a system that automatically tests and releases new code the moment developers finish writing it. This is called CI/CD, short for continuous integration and continuous delivery. In plain English, it just means new code gets automatically checked for bugs and pushed live without a human manually copying files around like it's 2005. Then you move into infrastructure work. You write code using tools like Terraform that automatically builds and configures servers instead of a technician clicking through menus by hand. You manage container systems like Docker and Kubernetes, which package applications into small, portable units that can run identically on any server, anywhere in the world. Think of Kubernetes as an air traffic controller, making sure hundreds of these small software containers land safely and run smoothly without crashing into each other. You also spend real time on something most companies underestimate until it's too late: security. This is sometimes called DevSecOps, which simply means baking security checks directly into the deployment pipeline instead of treating security as an afterthought. You make sure a vulnerability doesn't slip through and quietly sit inside production code for months. Beyond the pipeline itself, you're constantly thinking about cost. Cloud servers aren't free, and it's remarkably easy for a company to accidentally leave expensive resources running long after they're needed. Part of your job is watching spending dashboards and asking a simple question: are we paying for capacity we actually use, or capacity someone forgot to turn off? A single overlooked server left running for months can quietly cost a company tens of thousands of dollars. And catching that kind of waste is a normal Tuesday for you. You also live inside version control and automation scripts most people never see. Git, the system that tracks every change made to a company's codebase, is where your entire workflow begins. From there, you write automation scripts, often in Python or Bash, that handle repetitive tasks a human shouldn't have to do by hand, like spinning up a new server, applying security patches across hundreds of machines at once, or rolling back a bad deployment in seconds instead of hours. Here's a question worth sitting with. If a developer writes the code and a server just runs it, why does the space in between need its own highly paid specialist? Because that space in between is where almost every real-world disaster happens. A perfectly good piece of code can still bring down an entire platform if it's deployed the wrong way, to the wrong servers, at the wrong time. You are the person who prevents that. You build monitoring systems using tools like Datadog or Grafana that watch every server in real time, alerting you the instant something looks wrong, often before customers even notice. Let's talk numbers, because this is where it gets serious. Industry salary data from 2026 shows DevOps engineers earning a typical range between around $115,000 and $180,000 a year in the United States, with senior specialists in cloud-heavy or platform engineering roles commonly reaching $220,000 or more. Some of the highest-paid engineers in this space work as DevSecOps specialists, where the added responsibility of security pushes compensation even higher. Why does the money get that high? Because a mistake in this role isn't a minor bug. It's a company-wide outage. Every hour that a major platform is down, real revenue disappears. Real customers get frustrated, and real reputations take a hit. Companies aren't paying for comfort. They're paying to make sure that scenario never happens, or gets fixed in minutes instead of hours. Let's talk about who actually hires for this role. Every company with a serious digital product needs one. E-commerce platforms hire DevOps engineers to survive massive traffic spikes during sales events without crashing. Banks and fintech companies hire them to keep transaction systems running with zero tolerance for downtime. Healthcare tech companies hire them to keep patient systems compliant, secure, and always available. Gaming companies hire them to handle millions of players logging in during a new release. If a business depends on software running reliably at scale, this role exists inside it. You rarely work in isolation either. Developers come to you needing faster, safer ways to release their code. Security teams come to you to make sure nothing risky reaches production. Leadership comes to you when they want to understand why the platform went down, or how much a new feature will cost to run at scale. You are constantly translating between people who write code, people who protect the business, and people who fund it. Think about what that means for how replaceable you are. A developer who only writes application code competes with an enormous pool of other developers who can do roughly the same thing. You're not just writing code. You understand how an entire system behaves under pressure, what it costs to run, and how to keep it alive when something goes wrong. That combination is far harder to find and far harder to replace. This also shows up clearly in how responsibility grows over time. A junior DevOps engineer might own the deployment pipeline for a single application. A senior engineer often owns the deployment strategy for an entire company's infrastructure, spanning dozens of services and hundreds of servers, with real authority over how much the business spends on cloud computing every month. This cross-functional demand is exactly why the shortage exists. A recent industry survey found that the vast majority of organizations have already adopted, or are actively planning to adopt, DevOps practices. Nearly every company wants this skill set. Very few people are actually trained deeply enough to do it well. That imbalance between demand and supply is where these salaries come from. Let's be honest about the harder side of this job too. On-call rotations are common. If something breaks at midnight, you might be the one getting paged to fix it before customers wake up. This isn't a comfortable desk job where nothing ever goes wrong. But that responsibility is exactly why companies are willing to pay so heavily for people who can handle it calmly and competently. So how does someone actually break into this field? Start with the foundation everyone in this space needs: solid Linux skills. Almost every server environment in this industry runs on Linux, and being comfortable navigating it from the command line is non-negotiable. If that sounds intimidating, it isn't. It's a skill you build through repetition, not raw genius. Next, learn one major cloud platform deeply. AWS, Azure, or Google Cloud all offer certifications specifically built for this career path, such as the AWS Certified DevOps Engineer credential. These certifications matter for a very practical reason. Corporate hiring today runs through automated resume filters before a human ever sees your application, and a recognized certification is one of the fastest ways to get past that filter and in front of an actual hiring manager. From there, get hands-on with the core toolset. Learn Docker to understand containers. Learn Kubernetes to understand how those containers get managed at scale. Learn a CI/CD tool like Jenkins or GitHub Actions to understand how code moves from a developer's laptop into production automatically. You don't need to master all of these overnight. You need working familiarity with each one, backed by a small personal project you can talk through in an interview. Speaking of that project, build one. Set up a simple application, containerize it, and create an automated pipeline that deploys it whenever you push new code. This single project, documented clearly, will do more for your job prospects than any certificate alone, because it proves you can actually build the thing this job requires, not just describe it. Most people entering this field don't start with the DevOps engineer title. They start as a systems administrator, a support engineer, or a junior software developer. and pivot into DevOps within 1 to 2 years once they've built the right skills and a small portfolio to prove it. If you're already working in any IT-adjacent role today, you are likely closer to this transition than you think. While you're building toward that pivot, look for opportunities inside your current job first. Volunteer for any task involving deployments, servers, or automation, even if it's not officially part of your role. Ask to shadow whoever currently handles infrastructure at your company. Every hour spent near real production systems, even as an observer, makes your eventual interview answers sharper and far more credible than anything learned purely from a course. Finally, learn to speak in outcomes, not just tools. In interviews, you won't just be asked what Kubernetes does. You'll be asked how you would reduce deployment time, prevent an outage, or cut infrastructure costs. Practice explaining your technical decisions in terms of reliability, speed, and cost, because that is the actual language this role is paid to speak. One last thing that consistently separates hired candidates from overlooked ones. Document your practice project properly, even if it's small, and make it easy to share with a link. A hiring manager scanning dozens of similar resumes will remember the one candidate who can actually walk them through a real pipeline they built, instead of one more list of tools with no proof behind it. So think back to that number at the very start. $11,000 lost every minute a system goes down. That number is exactly why this role exists, and exactly why it pays what it does. It isn't reserved for a rare kind of genius. It's built for someone patient enough to learn Linux, one cloud platform, and a handful of core tools, and then prove it with a real project instead of a resume line. That person didn't need a computer science degree to start, and neither do you. You might be closer to your dream job than you think. Not because of luck, and not because of some rare talent, but because the path is clearer than it looks, once you know it exists. So like this video, subscribe, and comment your current job or the career you're chasing. You might be one certification away from a door you didn't even know was open. See you in the next one.